Hi everyone, this is your math guru. In this video, I'm going to show you how to find the volume of the given cone and also find the nature of the stationary value. Please don't forget to click on the like and subscribe button below for more easy to understand math concepts. The diagram shows a solid cone which has a slant height of 15 centimeters and a vertical height of 8 centimeters. One, show that the volume V centimeter cube of the cone is given by V equals a third of pi in bracket 225h minus h cube close bracket. And 2, given that h can vary, find the value of h for which V has a stationary value and also determine, showing all necessary working, the nature of this stationary value. I'm going to start with the first part of the question that says, show that the volume of the cone is given by V equals 1 over 3 pi in bracket 225h minus h cube. We've been given a hint for the volume of a cone, so I start with that. I have volume of a cone equals 1 over 3 pi radius squared times the perpendicular height. Note that the radius of the cone has not been given, so what I need to do is to find the radius of the cone. The perpendicular or the slanting side has been given, and note that we also have the perpendicular height as shown. So I'm going to use Pythagoras theorem to find the radius r. So if I draw out my rough sketch, I have that as 90 degrees. I have the perpendicular height, that's 8 centimeters. The slanting edge is 15. To find the radius r using Pythagoras theorem, so I have Pythagoras theorem that states that the square of the longest side, which is 15 squared, equals to the sum of the other two sides. So I have that as r squared plus h squared. Note that we're looking for r, so I'm going to make r squared a subletter formula. I have r squared equals 15 squared minus h squared. Therefore, r squared equals 15 squared, that's 225 minus h squared. I'm not going to find the square root of both sides to find r, because I can see from my equation that the volume is a third pi r squared height. So I already have the value of the r squared. So substituting for my radius or my r squared, I have the volume V of the cone equals 1 over 3 times pi, I leave that, times my perpendicular height, my h, times, I'm going to put that in a bracket, r squared 225 minus h squared. And because in the question given, I have the h multiplying the content of the bracket, I have therefore my volume equals 1 over 3 pi, then I have the h, I'm going to distribute that, so h multiplies all the terms in the bracket, and that will be in bracket 225 h minus h squared times h, that's h cube. For the second part of the question that says, given that h can vary, find the value of h for which V has a stationary value. To find the stationary value, we equate the first derivative to 0. So before I do that, I'm going to follow what I have. I have the content or the term outside the bracket multiplying the terms in the bracket. So I have my volume equals 1 over 3 pi h times 225 minus 1 over 3 pi h cubed. So therefore, equating my first derivative to 0, I have dv with respect to h equals, if I differentiate my volume, what I will have is 225 times 1 means 225 pi over 3 minus, then I have, if I differentiate that, I have 3 times 1, that's 3, then I have pi h to the power of 3 minus 1, that will become 2 divided by 3. Remember, I'm equating this to 0. So therefore, I have 225 divided by 3, that's 75 pi, minus 3 and 3, 1, so I have pi h squared equals to 0, so therefore pi h squared equals 75 pi. I have pi in pi, dividing both sides by pi, that goes off, I'm left with h squared equals to 75. And in order to find the value of h, for which v has a stationary value, I find the square root of both sides. So therefore, the value of h will be root of 75. And if I simplify further, that will be 5 root 3. Now for the second part of the question, I'm to determine, showing all necessary working, the nature of this stationary value. In order to determine the nature of stationary value, I need to find my second derivative. And in finding my second derivative, if my d squared v over dh squared, if the value is less than 0 or negative, then I'm going to say that is a maximum. And if my d squared v over dh squared, that's my second derivative, is greater than 0, then I say that will be a minima. So therefore, my dv dh, as calculated in the first part of the question, is, I have that as 75 pi minus pi h squared. So therefore, my d squared v over dh squared will be, that's negative 2 pi h. So, because I know that the value of my height is positive, what this means is this will tend to a negative number. And note that a negative number means that dv dh is less than 0, which is a maximum or a maximum. So therefore, the nature of the stationary value is that it is at maxima. Thanks for watching. Bye.